From 2014, I've had one particular vision: to spark change by embedding artificial intelligence into capital-intensive heavy industry. I studied at Cambridge and then Imperial and built my career in Silicon Valley, California, at energy supermajor Chevron. I was once told, dreams don't work unless you do, and this quote has remained with me, especially when times call upon single-minded focus. So it started with a what-if question. Google Earth has managed to map the landscapes of the Earth's surface. What if we could extend that downwards, 3 kilometers or more, into the interior of the Earth, which is where the largest volumes of natural resources lie, in rock formations deposited millions of years ago? Using a carpet of sensors planted on the seabed, spanning across hundreds of square kilometers, we will look at what's been made possible by my work at S-Cube and Chevron, optimizing $50 million well locations offshore Nigeria, Myanmar, Guyana, and in the North Sea. Let's start by setting the scene, in particular the digital transformation bringing about the so-called Fourth Industrial Revolution, based on the coupling of the physical and digital worlds. The digital transformation has revolutionized every aspect of human civilization. Simultaneously, it's caused demand for energy to soar to satisfy the needs of smart devices connected to the internet, streaming media on demand to keep us entertained. Previous industrial revolutions have brought us instant access to power and data. We're now on the cusp of a fourth industrial revolution centered around intelligent machines. The direct coupling of the digital and physical worlds involves sensors embedded into equipment, providing streams of data and AI-assisted operations. This is designed to bring about improved decision-making through harnessing the power of data, increased uptime through correcting hidden points of failure, optimized production through tuning equipment parameters, enhanced safety through remote monitoring, and reduced costs through eliminating wastage. At the heart of this are algorithms running on the cloud, consuming compute power by the petaflop, generating virtual reality environments for smart infrastructure, from buildings to factories to power plants to offshore energy production. So let's look at the role of S-Cube for maximizing recovery in offshore operations, with sensors on the seabed recording data from active seismic surveys, then feeding the data into algorithms for mapping the subsurface. So we'll now get into the commercial implications for the acreage holder. Here's an offshore wildcat well costing $50 million to drill. At a depth of 2.75 kilometers, the wellbore encounters a hydrocarbon-bearing zone with a height of 500 meters. Based on the predicted 3D geometry of the zone and the internal rock properties extrapolated away from the wellbore, the discovery is estimated to consist of 500 million barrels of resource. Determining the future cash flow from this production, extracted over a duration of 20 years, the net present value per barrel is $3. This gives the acreage holder a net asset value of $1.5 billion from this single successful drilling decision. Let's now look at the S-Cube growth strategy across a province like the North Sea. In 2018, S-Cube Exploration Services launched on the AWS cloud. New users are charged a rate of $200 per square kilometre per application of the AWI algorithm on acquired seismic data. There are tens of thousands of square kilometres over hundreds of fields in the North Sea where this service will be deployed for reducing drilling risk and maximising subsurface recovery. Clear to see the relation between business and science in the digital transformation. We see the likes of Bezos and Dyson using this powerful combination for creating breakthrough products and brands. The digital transformation is probably best symbolized by the explosive growth of free-to-use internet services powered by complex algorithms and data servers, scaling to billions of users across the globe. The flip side of this is high street decline. Shops, cinemas, travel agents replaced by online counterparts, Amazon, YouTube, Expedia. It's also affecting professional services, accounting and legal work turning into software, and back office work is reducing its human dependence from quote to cash. Next, we have an application where we've eliminated human requirements completely to perform the task of competitor intelligence for the London Town Group hotel portfolio. A selection of LTG hotels are shown along the left and future stay dates along the top with rate and availability in the table. The tool is based on a bot crawling the internet, finding out competitor rates and providing alerts when they change. The values are updated every 15 minutes, so faster and more accurate than a human could ever manage. Let's turn attention to one of the hotel sites, located on the doorstep of Paddington Station. Paddington has become the gateway to London by virtue of the Heathrow Express. There are millions of travellers, domestic and international, as well as office workers passing through it every month. The building currently has 5 floors, with 86 densely packed rooms. Following on from Paddington Cube behind it, it is in planning to become a flagship 18-floor luxury lifestyle boutique hotel with double the room count, which will cater for the expected surge in extra demand in the area. The building will be industry-leading in terms of digitalisation and using this as a catalyst for decarbonisation. Smart rooms will be equipped with AI precision control for data, power, connectivity and comfort. The building will be designed to make use of fuels of the future like hydrogen. This, combined with advanced energy demand management, will target 35% carbon emissions reductions. So in summary, the fourth industrial revolution is the coupling of the physical and digital worlds. It's optimizing both energy consumption and generation. It's leading to smart infrastructure from buildings to offshore operations, creating both winners and losers in the process. So reiterating my vision to spark change through embedding artificial intelligence into capital-intensive heavy industry, we will now look at my progress in delivering it. S-Cube Exploration Intelligence Company forms in 2014 based on my PhD thesis and agrees a joint venture with Imperial College London, enabling direct access to Imperial's supercomputer resources for performing large-scale parallelized data processing. S-Cube invents and patents the new Adaptive Waveform Inversion AWI data processing algorithm and wins an industry breakthrough award at the EAGE 2015. In 2016, S-Cube wins multi-million-dollar AWI software licensing contracts with 2 operators, Equinor and Woodside Energy, directly leading to a multi-million-barrel strike offshore Myanmar. 2018, S-Cube develops and launches the first ever pay-as-you-go cloud business model for the energy sector, running on the AWS cloud, charging users per square kilometre scanned. Pilot program rates of above $200 per square kilometre are achieved, with cloud users scaling up to areas of thousands of square kilometres per project. 2019, S-Cube is providing exploration services for a major upcoming drilling campaign in prospective Central Atlantic margin acreage for Tullow oil, targeting over 1 billion barrels of resource. Beyond energy technology, London Town Group launches 2 cloud-based hotel technology platforms, Flexi Bookings for Book by the Hour in 2017 and Hotel Dynamics for Competitor Intelligence in 2019.